we're kind of gonna, you've got the 5 marks here, which are reasonably kind of straightforward, and then the 6 marks, which really are going to test us our geometric reasoning. So the bit in yellow here is the cosine rule from the formula book, which we are going to actually use for part A. So it says to show that theta equals 0.586 correct to 3SF. So we're going to start off by looking at what we've been given on here. Now we've been really fortunate because the question itself has labelled the unknown angle theta as angle A. So our 5 is opposite the A, our 9 is opposite the B, and our 8 is opposite the C. So they're the small case letters. So we can say then that 25 squared equals B, which is 9 squared, plus 8 squared, minus 2 lots of 9 times 8 times by cos, not of A, but of theta. Okay, so what we're doing here, sorry, it's not 25 squared, it should be 5 squared there. So we're just substituting our numbers into our equation, and already our examiner's going, right, they know what cosine rule is, they've got a mark. We now need to just evaluate everything that we've got here. Now, when you're doing the exam, I suppose you could put it straight into your calculator and come out with what you've got, but you're doing a show that. So it's not just saying what's theta, it's saying show that theta is this. So we do need to show our steps a little bit more. 25 equals 81 plus 64 minus 2 times 9 times 8. Now, because I've got it here, I'm just going to use this to confirm that 2 times 9 times 8 is in fact 144. So 144 cos theta. Now let's rearrange everything. So it's 25 minus 81 minus 64 divided by minus 144 is going to be equal to cos theta. Okay, so that's just moving the 81 and the 64 over and then dividing by what cos is being multiplied by. So then back to my calculator. Let's just come off the screen a little bit. Back to my calculator, let's just pop these numbers in. So obviously what I'm doing here is I've shown my examiner what I'm going to do, and I'm now just doing it. So there we go, 144. So that comes to 5/6. So cos theta equals 5/6. Now, before I carry on, I'm pretty aware that my calculator is unlikely to be in radians. So let's just make sure that it is. So change your calculator into radians there. So because everything's in radians because the question says it's in radians. So I'm now going to do inverse cosine of that 5/6. So inverse cos of my answer. And I get this long number here. Now, an interesting sort of point in the mark scheme is that they wanted you to write out this number, or a bit more of this number, to show that it rounds to 3. So to be absolutely certain that you get all your marks, you want to write down theta equals 585.6 855. Let's go 855. And then say that rounded to 3SF is 0.586. Okay, and in doing that, you're just guaranteeing that you've completely just show that. You've done everything. There's nowhere the examiner can say, well, you haven't shown that step clearly. Okay, so that's our first 3 marks. I'm going to clear away this workings now before we do part B of this question. Okay, so part B asks us to find the area of the triangle. Now, the first thing we have to do is we have to know how to do that. So it's a half AB sine C is the fastest way. Okay, whether it's the only way, we can have a discussion about that if you really want, but I'm reasonably happy that I'm going to go for this method. Now, the angle, which I do now know, has to be C. So I need to do some reworking of my triangle. And this is where some of my students did lose marks, because you need to then say, well, this is now C. Okay, 0.586. So we've got C there. We need to just then label A and B. And it doesn't actually matter which of the two sides we label A or B, but we just need to make sure that we know that they are 8 and 9. Because if we use the 5, we get the wrong answer. Okay, so we've got all of our information now. I'm going to use A as 9 and I'm going to use B as 8. So it's half times by 8 times 9, and that's why it doesn't matter, because it's either 8 times 9 or 9 times 8, times by the sine of 0.586. So this is then just a bit more calculator work for us. So putting all this information into our calculator, we've got a half times by 8 times by 9 times by the sine of 0.586. And that comes to 19.9, and three significant figures, so I'm just going to leave it as 19.9. So that equals 19.9, giving your answer in centimetres squared. So it's just worth writing that down. Make sure that we don't lose any marks for silly mistakes like forgetting our units. So 19.9 centimetres squared for part B there, which tells me the area of the triangle. And that moves us nicely into part C. So part C is the geometric reasoning element of this. So the circular sector, centre A, radius R, is removed from the triangle ABC. So we've just found out the area of the triangle ABC, and we know additional information into this picture that theta is 0.586 radians. The remaining shape is shaded in the diagram below. Given that the area of the sector removed is equal to the area of the shaded shape, find the perimeter of the shaded shape, giving your answer in centimetres, three significant figures. So the area of the sector removed is equal to the area of the shaded shape. So this section has the same area as that section. Okay. Now we know how to find the area of a sector. It is the formula half r squared theta, area of a sector. And what we're saying is that is equal to this section here. So they're the same size. Now, if we take our 19.9, our area of the entire thing, and we subtract this formula here, we get the same formula. So this, if you like, is the area of the sector. This, if you like, is the area of the shaded shape that we're trying to find out. But we've been told that they are the same. So we can effectively say, well, they're the same thing, they're the same formula. Now, from here, we can then sort of start formulating an equation to find the radius. So we've already found out, we've sort of given it in part A what theta was. So theta is 0.586 radians. So I'm going to rewrite this now with that in tow. So 19.9 minus 0.586 over 2 r squared equals 856 over 2 r squared. Now, bringing this, we're trying to find r. So I'm going to bring my two terms in terms of r together. So 19.9 equals 0.586 over 2 r squared plus the one from this side. So plus 0.586 over 2 r squared. Now, if you want to, if you're not happy with this step, evaluate what this is. So evaluate 0.586 over 2 plus the same thing again. But what you will, if you're kind of following this quickly, you will see that actually, well, that's just going to give us 0.586, sorry, because you just got 586 over 2 plus 586 over 2. So 19.9 equals 0.586 r squared. Divide by 0.586 both sides, we get r squared. So that's one I will need my calculator for. So 19.9 over 0.586 gives me that r squared is equal to that number there. Now, I will write that down in a second, 33.959 but obviously I want to use the answer function of here. So I'm going to now square root that to find out my radius. So my radius is 5.827. Okay, we could be considering plus minus, but you can't have a negative radius, so we need to keep just the positive 5.827. So R is 5.827. Okay, so what we've done is we've read the question through. Let's just zoom out a bit so we can see everything we've done. Read the question through, and we've said that the area of the shaded section, which is the bit that we wanted, was the area of the whole triangle, take away the area of the sector, and it just so happened that the area of the sector and the area of the shaded shape are equal. We've then worked that through, so from this point here, we're now working our way down, substituting in what we know theta, and rearranging to find out R. Okay, so coming back up then, what information have we just got? We've just got that R is equal to 5.827. And now let's have a look at what we've been asked to do. We've been asked to find the perimeter of the shaded shape. So the shaded shape is this sort of thing here. Currently, I know that length is 5. This length here, this whole thing, this is 8. Take away the radius. So this top bit here is 8 minus 5.872. Okay, and this bottom one, it's the same thing. 9, take away a radius. So 9 minus 5.827. This thing here, this bit here, is the arc length of the original sector. So arc length, is found by doing r theta. So 5.827 times 0.586. So that's going to give us that bit there, the arc length. So now I just need to evaluate these 4 things to eventually add them together to give me the perimeter. So 9 minus 5.827 is going to give me 3.173. This one up here is going to be 2.173, but let's just double check that we haven't done anything particularly crazy. So we do get 2.173. And then finally the arc length, which is 5.827 multiplied by our theta value 0.586, which comes to 3.414. Now I'm working everything here, you'll see, is in 4 significant figures, which allows me to then correctly find my answer in 3 significant figures without worrying about a rounding error. So the perimeter is the sum of the 4 things I've just underlined. So just for completeness, I'll just write that out. It's 5 plus 3.173 plus 2.173 plus 3.414. And in adding all those together, I'm then going to get the perimeter of my shape. So very quickly, just popping all those into your calculator. And I get the correct solution of 13.76, which I'm going to round to 13.8 centimetres for the final perimeter of that shape. So just to recap, we've already recapped this whole section, so we found out what R was, and then we just substituted R into this situation to find out the perimeter of the shaded section.